Hello guys, welcome to our channel Raw and Basic. So today we will learn on how to compute your maturity or future value in the environment of your compound interest. Again, we will be computing and understanding the concept of your maturity or future value of compound interest. Okay, so let us start. So on the board, I have here some equation or formula in dealing with computing your future or maturity value. Again, for those who are not acquainted with maturity value, so maturity value or again, future value is another term for your maturity value. Okay? So we have here compounding once a year and compounding more than once in a year. Okay? So I guess that you already know that there is some differences between compound and simple interest. So to be familiar with simple interest, you can watch some of my video. Okay, so let us start. So compounding once a year, we will be using this formula F equals to P times the quantity of 1 plus R raised to P. So on my video about exponential functions, this one, I've already discussed this compound interest as a contextual example of exponential function. So I will write f equals to p times the quantity of 1 plus r raised to p. So this is an exponential function where the exponent is your t time, or it can be written using your function form f of t equal to p times the quantity of 1 plus r raised to p, where p is your initial value and this quantity 1 plus r is your growth rate and t is your exponent. So if you will try to watch that video, the basic form of this thing is a b raised to x, where b is equal to this quantity, a is the initial value p, and x is your exponent. So in this case, we have t. Okay? So if you're interested, you can watch some of my video about exponential function. Okay, so let us focus on these things. So if you can see, we have here on the other side, we have compounding more than once in a year. So why is it so that we have once a year and more than once in a year? And if you can see this equation or formula f equal to p times the quantity of 1 plus r raised to t is much more easier to grasp on than this one. So we have f equal to p times the quantity of 1 plus a difference between I raised to m over m raised to mt. Okay? Or, to summarize this formula or equation, we have this one, f equal to p times the quantity of 1 plus j raised to n, where this I raised to m over m is equal to j and mt is equal to n. So I will discuss it further later, but first let us identify these terms. So of course, f and p are already discussed on the other videos, but let's discuss these things. So f equals maturity or future value. Okay? Then p is your principal or present value. So principal is a general term used for compound and simple interest. But in compound interest, a principal can be your present value. if you're interested, again, you can watch the illustration and the differences of compound interest and simple interest. There you can find the term present value and how you can define it by illustration. Now let's proceed to R. So R, this R, is the annual rate of interest. Okay, your ordinary R, rate of interest, usually in percent form. Then we have T, okay, usually in percent form. T for time or term in years. Okay, then I raised to M, this thing. I raised to M is your nominal rate, just like your annual interest rate. So we will get to that later. Then we have M, the frequency of conversion in a year. Okay, so I will discuss this frequency of conversion later. But M denotes the frequency of conversion in a year. Then N is the total conversion within the term. And we can compute that N using M times T. This one. Okay? Then J is equal to the rate of interest for each conversion period. Or we can solve that one using I raised to M divided by M. This thing equal to J. Okay? So please remember these terms and variables because we will be using these things to compute for your compound interest. Okay? So let us proceed in here because these things are very important. So we have the frequency of conversion denoted by M. Okay? Here, the frequency of conversion denoted by M. So if the frequency of conversion is annually, the value of M is 1. Okay? That means the interest, or I will explain that later. So when we say annually, the value of M is 1, it means every year. So you can search your dictionaries if you have one. So annually, the value of M means every year. We can apply that on this thing. Compounding once in a year. Okay? Therefore, in here you cannot see any variable M. If we will base it in here, M is divided on your rate. So rate is divided by M and multiplied to your T. It's like that one. But on annual conversion, M is 1. So R will be equal to F equal to P 1 plus R divided by 1, then T multiplied to 1. So R divided by 1 remains R. Okay? Then T multiplied to 1 will remain T. That is why the formula or equation in computing your maturity or for future value compound interest once in a year is this one. You cannot see M there because M is equal to 1. It means that we are compounding once in a year or annually. Okay? So I guess that you have a grasp of that. Now let us proceed to this thing. Semi or semi-annually, the value of M is 2. It means the conversion period is every 6 months, or the interest will increase every end of 6 months. Then quarterly, from the root word quarter, it means 4. So if you divide 1 year by 4, it will be 3 months. Okay? And say semi divided by 2. So if we divide 2, or if we divide 1 year by 2, we will have 6 months. Semi divided by 2, or half. Then quarterly means, quarter means 4. So every end of 3 months. Then monthly, of course, every month. So we have 12 months in a year. So the value of M will be 12, of course. And daily, and the term is daily, or the frequency of conversion is daily. The value of M is 365, of course, very self-explanatory, and daily, or we can say every day. Okay? So just remember these things, and because they are the basic terms and variables that we will be using in computing your maturity or future value. So let's go to the application of this formula and terms to our problem. Okay, for our first problem, we have here on the board, find the maturity value and interest if 10,000 pesos is deposited in a bank at 2% compounded quarterly for 5 years. Okay? So again, we will follow the steps in solving your problems. For situations like this, let us first identify the given data or information from the situation or the problem. We have here 10,000, so that will be your principal P. So you have 10,000. Then we have R, your rate, equals 2%. Okay? Then we have here compounded quarterly. That will be your M. So let's move this thing first, conclusion. Okay, M is quarterly. To make it clear, for it is quarterly, we can say that the value of M is 4. So every end of 3 months, or when we say conversion, a number of conversions, how frequent or how many times does your interest gain or earn each year? So 4 times a year or every 3 months. Okay? Then we have time T equal to 5 years. Okay? So R first will be converted into decimals. So we have 2% divided by 100 equals to 0.02, or that is 1/2. Decimal is 0.02, or you can add 0 to make it prettier. Okay, so we have 0.02. Then the require is, we have here 2 unknowns. We have your maturity value. Okay, so your maturity value, or other term is future values, denoted by F. And the interest, of course, because we are dealing with compound interest. Of course, that interest is your compound interest. Okay, unlike your simple interest that we are solving your simple interest I sub s as multiplying the p, the r, and the t, we will be getting your compound interest I sub c using this f is equal to p plus I. In general term, your future value is the sum of your principal and the interest. Of course, we can use this formula. Either you are solving your future value in compound interest or in simple interest. The future value is always equal to the principal plus the interest. Okay? So later I will explain and derive the equation I sub c from this thing. Okay, for your solution, first let us focus on solving your maturity or future value f. Okay, so we have f is equal to p times the quantity of 1 plus, from your book, we have I sub m over m raised to m times t. But if you can see in here, there is no I raised to m on your given dicta. Okay, so I will rewrite this equation and explain. We have f equal to p times the quantity of 1 plus r over m raised to m t. Okay? So I sub m is your annual or nominal rate r. So it depends on you on what variable you will be using to denote your nominal or annual rate. From my reference, they are using I raised to m to denote this annual rate. Okay, so that's why I am writing here I raised to m over m raised to mt. So it is the same whether you put r or write r there, replacing your I raised to m. Depends on you as long as you understand the concept behind. Okay? So either of the two. But if you will be asking me, I will use this one so that my audience will not be confused. Where is I raised to m? But to make you familiar with I raised to m, on our given, our I raised to m, which is 4, is equal to 0.02, of course. So I raised to m, and m is 4, right? So we have I raised to 4, or the nominal rate is equal to 0.02. That is why, in my case, I am using r to denote this annual rate to avoid confusion. Okay? So it's up to you whether you will use this one or this one. Okay, so they are the same. So we have f, substituting your p, which is 10,000. This one. Then we have times the quantity of 1 plus, again, your r or I raised to m is 0, sorry. There's a fraction bar in there. We have 0.02 over m, which is 4, raised to m t. M is 4 times t, which is 5. Okay? Then to continue, we have f. F is equal to 10,000 times the quantity of 1 plus this thing 0.02 divided by 4 is 0.005. You can use your calculator. Then raise to 4 times 5, and that is 20. Okay? Then of course, using your calculator, or if you have the time to compute this thing manually, you can manually compute this one, but in my case, I will be using a calculator. So we will have 11,000 0.89557 and so on. So we have this digits 11,048.95571 and so on. But the concept behind this digit or quantity, this digit represents money. So we will be converting this digit into 2 decimal places, or we will round it off to hundreds or 2 decimal places. So we have F is equal to 11,048 pesos and 96 centavos. So the reason behind it, we are rounding it off to 2 decimal places because this 0.96 is in centavos or cents. So it will be hard for us to identify this decimals on the case of money. Okay? So I guess that you understand the concept behind. So the future value is 11,048 pesos and 96 centavos. Okay. So I will explain another formula if you can see on your books. So I will erase this thing. Some of the books are using this formula. As F equal to P times the quantity of 1 plus J raised to N. So if you can see, this thing I raised to M, the nominal rate divided by M is equal to J. So it's just like summarizing the equation to reduce the variables and to make it more simple. So we have J is equal to I raised to M over M, and N is equal to M times T, the frequency of conversion times the term time or time. Okay? So it's either this formula tells us before we can substitute, just like on this step, first you can solve your J. So J in there is I raised to M over M. So J is 0.02 divided by 4, and J is equal to 0.005. Okay? And N is equal to MT. So on our first example, MT is 4 times 5. So N equal to 20. Okay, it's just like putting this one. F equals to 10,000 times 1 plus 0.005 raised to 20. Okay, it's just like this one. They are just summarizing the variables to make it look easier, and you will directly will be proceeding on this thing. But in my case, I will substitute from the original formula or equation, F equal to P times the quantity of 1 plus R over M raised to MT, because you will arrive at the same answer in this thing. So it's up to you. Either you will solve first this J or this I over M or R over M and multiply this MT and substitute, or substitute and solve. This one, they solve first the things and substitute. Okay? So I guess that you understand the concept. So we already computed your future maturity value. Now let's proceed to computing your compound interest. So computing your compound interest, we will be using F equal to P plus I as a general equation or formula in solving your future value if P and I are given. Or, to make the long story short, we are dealing with I sub C or compound interest. But you can use this formula in dealing with your simple interest. Okay? But let's forget the simple interest and proceed to compound interest. So the very basic form of understanding this one is state 15 is equal to 10 plus 5. Example, you are investing 10 pesos and the 10 pesos earned 5 pesos. Of course, the total money you will have is 15. Okay, if you will have to get this 5, so you have to subtract 15 minus 10 equal to 5. So that thing is just like this one. F equal to P plus I sub C. To isolate I sub C on the other side, minus P minus P. P will be eliminated. What's remaining is I sub C. So we have F minus P. 15 minus 10 equal to 5. Just like F minus P equal to I sub C. Isolating I sub C or writing it the proper way, we have I sub C is equal to F minus P. So we will be using this formula or equation in computing your compound interest, I sub C. Okay, let's go. So I will erase this one. So we have F is equal to P plus I sub C. Then I sub C is equal to F minus P. So compound interest is F. We have computed already your F, which is 11,048.96 minus P from your given, which is 10,000. Then the compound interest is minus 10,000 from 11,048.96. So we have 1,048.96. Okay? So your future value or maturity value is 11,048.96, while your compound interest 1,048.96. Okay, for your conclusion. So the conclusion will answer all the questions of the problem. Okay, conclusion. At the end how many years? 5 years. The deposited money in a bank which is 10,000 pesos will earn, how much will you earn? 1,048.96. So we'll earn 1,048.96 interest at 2% rate, compounded quarterly. Okay? Then the maturity value will be 11,000 pesos, 11,048 pesos and 96 centavos. Okay, I guess that we are clear on these things. So if you can see some error and you have some suggestion, you can write it on the comment section. Okay, let us proceed to another example of computing your maturity or future value compound interest. So on the board we have here, Paul borrows 50,000 and promises to pay the principal and interest at 12% compounded monthly. How much must he repay after 6 years? So on the board we have here some steps to be followed for us to solve this effectively. Okay, so first let us identify the given. So the given information are, of course, we have 50,000 and that will be your principal. So 50,000. Okay. Then we have 12%. That will be your rate. Or in some books, again, it is denoted by I raised to M. But in my case, I will denote it as R to avoid confusion. So R is equal to, converting 12% into decimal, just divided by 100 and it will give you 0.12. And we have here M, compounded monthly. So monthly, that will be 12. Again, the values of your frequency of conversion, we have 12, 4, 2, and 6. So just review your video on how to get the values of M. So if it is quarterly, it will be 4, semi-annually 2, annually 1. So because it is compounded monthly, M is equal to 12. And we have time T equals 6 years. Okay? So explaining J and N. So J is I raised to M over M, or can be R over M. And J is, on our case, we have 12% divided by 12, and J is equal to 1%. So it means that it is the interest rate per conversion period, or on our case, it will be 1% per month or monthly. Okay, so we have 12% for the whole year. Again, this 12% is the annual or nominal rate. This is the rate of interest each year, but it's compounded monthly, so 1% monthly or per month. Okay, so that is the difference between J and R, or I raised to M. What about N? So N is the total number of conversion period. So it will be M times T. So in our case, our M is 12 and T is 6 years. So it will be 72. Okay? So 72 times your money will gain the interest. This interest. Okay? So using a timeline, so we have 0, 1, 2, 3, 4, 5, and 6. So these numbers are the years. 1, 2, 3, 4, 5, 6 years. So each year, we have 12%. Okay? Then let's divide each year by 12. So we have 1% per conversion period or per month. Okay? So we will be dividing this or each year by 12 because it is monthly. If it is quarterly, we will divide this by 4. If it is semi-annually, we will divide it by 2. Okay? So, on our case, so each year is consists of 12 conversion or frequency. So, at the total, we have 72. So, from 0 to 6, we have 72. And that is your N. Your J is 1%. Your R or I raised to M is 12%. Okay, so that is the difference between the nominal rate and the rate per conversion. And the total number of conversion, 72. Okay, so I guess that you understand the concept. Now let us proceed to the main agenda of your situation or problem. So the required in here is the principal and the interest. So principal and interest is equal to your future value. So of course, the unknown or the required in here that we need to solve is the maturity or the future value, denoted by capital F. Okay? Then for our solution, we have F. Let's use this one. P times the quantity of 1 plus R raised to M T. Again, you can use these formulas if you are comfortable with these things. Depends on you. Okay, or this one. So I'd explain that I raised to M over M is equal to J, and M raised to T is equal to N. So it's up to you what formula you will use, but in my case, if you'll be asking me, I will be using this one. So R and I raised to M are the same. So we have F, continuing, substitution, P is equal to 50,000. times the quantity of 1 plus R is 0.12 divided by M, which is 12, quantity raised to M, which is 12, times T, which is 6. Okay? So erasing this one. To continue, we have F equals 50,000 times the quantity of 1 plus 0.12 divided by 12 is 0.01 raised to 12 times 6, that is 12 times 6 is 72. F equals 50,000 times the quantity of 1.01 raised to 72. And F is equal to 50,000, Computing this one using your calculator, you can arrive at these digits. So we have 102,354 pesos, 0.965605, and so on. So rounding it off to the nearest hundreds, or shall we say 2 decimal places from here. So we have, okay, let's erase this one first. We have 102,354.97, or in money we have 102,354 pesos and 97 centavos. So again, we will not include these digits when we are speaking about money, because the concept is what amount of money is this, okay? By common sense. So conclusion, okay? Going back from here, if you are using a calculator, of course, after you input these things and pressing equals, you will arrive on these things. So it's up to you whether you will solve it one by one, just like this one. So if you will be asking me, less mistake, less solution is less mistake. So just input this one and press equal to get to this. So I've just written these things for you to understand it better. So let's go to your conclusion. To answer the question, how much must he repay after 6 years? So Paul must pay 102,354 pesos and 97 centavos after 6 years. Okay? So that is our conclusion. So that's the end of our video. I guess that you have learned something. Thank you so much for watching. Please subscribe if you have noticed or observed some errors, or if you have some suggestions, please type it on the comment section. Thank you so much and stay safe.